Going live. You're live.
Hey,
Okay. Hello, everybody. Welcome back to the Architecture Weekly YouTube channel. And today we're continuing our series of interviews with some folks from the IT industry. Today, I'm pleased to announce that we're having Andrey Rebrov, who is a CTO of Scentbird and co-founder of the same company. And he's producing legacy code since 2014. Welcome, Andrey.
Vladimir, and thanks for having me here.
Yeah, very nice to have you. So yeah, pleasure to myself and hopefully to our viewers. So what we're talking about today is microservices. So basically how we came up with the idea of microservices, how they're doing today, what are the problems of them, how do we live with them in production, and where do microservices really go? So let's start. Andrey, can you please give us a short, historical introduction in like how we came up with the idea of microservices?
Sure. So the original idea of microservices, if I remember correctly, came as a solution for the problem of growing companies. Because when you are a company and you add more and more features to your product, at some point it becomes really hard to scale it because you have to define who's responsible for which part of the code, for which line of the code, for the class, and so on and so forth. And it creates more and more complications with every feature added. So at some point, the decision was made, what if our architecture will actually look like our organization? Here comes the famous principle that every company architecture is mirrored by the organizational structure. So
Conway flow.
Yeah, exactly. So the idea here, every team is now responsible for certain functional piece of the application, not the code, but the application. And they have to define how these functional pieces talk to each other. So is it an API? Is it some database connection? Is it something else? And I would say the company who led it to a certain extreme level is, at least for me, is Amazon, because at some point Amazon told their employee, hey guys, from now on, we don't let people inside talk to each other. They should communicate through the APIs and through the documentation for this API, because we see it as a way to grow organization, as a way to grow our business, because that is the ultimate goal, not just make it an interesting challenge for engineers, not just write another article or book, but ultimately to grow the business. And that's actually my biased view on all these topics, because as a CTO, I'm not only responsible for the code quality, I'm also responsible for the product delivery, for hiring, retaining the engineers, for making sure that we actually improve our business, improve our system, not just having fun and doing some CI/CD pipelines.
So one month. So basically, you're saying that the microservices was not a technical challenge in the first place, but rather you mean to scale the organization and speed up the development. Is that correct?
For me, it is the same, because as soon as your engineering team slows down and can't keep up with business demand, then it quickly becomes the problem of the business. So at some point, business can, as we all know, like we can ignore the technical debt forever, but at some point it will come back and bite us. The same with the complexity of the code, complexity of the architecture. We can keep just adding features here and there, code pieces here and there. At some point it will bite us, and then we will have to think about the architecture. If the timing is not right, we'll lose the competition and someone else will win the market.
Okay, got it. But what about this argument that hey, we need to have microservices because there's a limit of vertical scalability, and in order to support the enormous amount of users, like 3.5, we need to scale our monolith, and we just can't pick up the appropriate virtual machine.
That's a fair point, because as always, every problem has multiple views, and one of them is actually how to scale, because at some point certain companies actually have a little bit more than 3.5 users, like 3.5 million users working with the same product at the same time. And interestingly enough, not interesting, I would say, obviously enough, the load is not equal to all parts of the system. We can have more people browsing our landing pages, we have less people on the login page, and then we have very little people who actually access our backend. But still, on like when we go internally, it could be just a few databases, it could be just a few, service here and there. So we have to think about it carefully. So I would say that's another problem to solve. But for me, at least how I view it, first comes the problem of communication and the responsibility, because we can see it even on smaller teams, even without scalability, who is responsible for which functionality, especially when we are working on a big and complex flow on the website. Like that starts with the website visit, then the checkout, then order processing, then certain manipulation around this order, and then communication with the customer around the order status. I'm obviously taking all the examples from my e-commerce and subscription background, but this is a perfect example when website teams have to talk a lot with the back office teams, have to talk a lot with mobile teams, and so on and so forth. So communication is always a problem. It will be never solved because it's a human nature. But yes, once you solve this, like you can effectively work on the monolith. Then comes the next problem: how to properly scale it. And this is where monolith allows you to scale. This is where microservices allow you to scale exactly the right part of the system, because if you scale the monolith, you just consume incredible amount of servers, and this is not right. And that's another problem your CTO or someone responsible for your technical budget should solve. How do we scale properly and don't just consume all our budget with AWS build?
Okay, so this is an important highlight for me. So saying that different parts of the system, I actually have different sets of functional, non-functional requirements. And basically this is another reason to, try to separate them somehow.
Mm-hmm.
Okay. Then like if we understand the reason why we have the microservices, then we might want to understand what's the state like. What's the state of adoption of microservices right now in the industry? Are they like widespread, or is like only like big companies are doing that, or like everybody is doing that, and how it's technologically supported?
I would say microservices, as any other technology, as any other movement, also went through the famous adoption curve, when in the beginning you have people who are extreme experimentalists. They would love to try anything new. Then at some point, more and more people start to use this. And then in the end, you have what is the term there? Laggards, something like that. So people who are always against any change. And I can say with microservices, it's still the case that a lot of people who say, I don't think that's a good idea. I have a perfect PHP monolith, or I have a perfect Go monolith. It works for me. And that's actually fine. Like any technology solution, it's not a silver bullet for every case. In many cases, it's fine to have a monolith. There are a lot of successful businesses, a lot of successful services, technologies who work fine as a monolith. So we shouldn't, that shouldn't be the case. Like if you work on the technology, you should immediately start thinking about microservices. No. So in many cases, monolith is still a great thing to have. And in many cases, microservices will be actually an overcomplication that will only create troubles than solve some hypothetical problem. So again, that's one part. Second part, we as a technology, we as an industry always love to argue, and whenever there is a question what is better, A or B, there will always be and forever will be an arguing, is A better than B, or maybe B is better than A, and there will be never an agreement that this is the right answer. So that's one. Second, at some point, microservices were moved to an extreme level. So instead of, hey, let's group everything related to user, for example, into the user microservices, let's go extreme and move every function around user to its own microservice. Here comes the Lambda functions. So like one of the famous example, at least for me, of the company who adopted to extreme level is the iRobot. It's I remember, I think it was 2017, and it was an AWS summit when they were talking about, hey, our entire operation, our entire robot only uses Lambda functions, and we are great. Maybe that's a good approach from like overall, but personally, I don't like I don't like robots. But again, like we are getting into the Hollywood territory there, and the performance of the robots is not about the lambdas on the backend.
I remember the story of interviewing a guy for some of the previous companies, and we were working with microservices a lot, and we asked him like, what's your attitude toward microservices? So what's the granularity you would like to pick? And the guy was like, every function should be a separate microservice, like literally everyone. So it's like, yeah, extreme.
But there is also another thing to keep in mind when we're talking about microservice, because it's not only about the code, it's also about the whole infrastructure around it, because these are servers, these are networks, these are monitoring systems, these are analytics, and so on and so forth. So when microservices were just invented as a concept, a lot of things to make it easier to adopt microservices didn't exist. Like we didn't have Docker, we didn't have Kubernetes, obviously, we didn't have simple solutions to monitor the stuff, we didn't have simple monitoring that allowed us to go through all of the connections and so on and so forth. So once the market started to produce tools that were easy to use, that were easy to learn, that were actually working with each other properly, then I would say microservices as a concept become way more adopted than before, because you still need to solve these infrastructure problems but before you adopt microservices, no matter how much you love microservices. So I would say simple virtualization and containerization become a big and important step for all the companies to adopt microservices. Obviously, once the Docker was introduced, we started to experience a different kind of problem. But I would say this is a big and multicolor story of containerization in general. And I think we will keep it for another day. But I would say containerization was important. Again, that's also not the whole story. Engineers solve their problem, everything scales perfectly, everything works perfectly. Now, how to test it? Like how do we run the staging environment? Now we have 2,000 microservices. What should be a staging environment? What should be a mock? How to test for the performance? How to generate testing data? How to give it to QA team? What should they test? Then we also multiply this situation by usage of the Git flow. Now we have multiple services. Now we have multiple branches. Now we have multiple teams. Now we have multiple roadmaps. So how to test it all? So I would say every time there is a successful use case, and it's, in many cases, it's not about the technology, it's about how people approach this problem. Every time there is a successful case study, how certain companies solve their microservices cases, adoption of microservices grows. And I would say now, in many cases, when we talk about company at a certain size, by default, every engineer who read about this company assume that they have microservices inside, and in, I would say 98% of the cases, they're true.
Okay, so basically the adoption of microservices is widespread, right?
Yep.
But I still want to talk a little bit about the problems that we have in microservices, and we couldn't even imagine having a monolith, right?
Mm-hmm.
So because in monolith, it's all very simple aside of deployment, of course, and, you know, starts in a web sphere, waiting for it for 20 minutes. But yeah, generally in a monolith, you want to call a function, just call it, right? You can be sure that this will be either invoked properly or you will get an error, right? There's no problem with state synchronization, so you can always have a connection. You can always have a consensus, right? So you can be sure about the consistency of your data, and like you're monitoring a single piece of a runtime, right? So there's no set of the problems there. Can you give us more light of such a problems that didn't exist in monoliths, but in microservices, like you face it every day?
Sure. So that's actually let's go the dark side of microservices, because the number of problems that exist there is large, and partially is I'd say not partially, it's all it to us human, but in many cases it's just the imperfection of the current technology. So let's start with a simple situation. You need to call a function. So very simple situation that can happen with anyone. What if the function on the other side needs to be changed? So how to do it properly? So do we support the multiple versions of the API? If yes, at which point we stop supporting the old ones, especially in the large organization, and where there are a lot of consumers of the function. Obviously, at some point, we can go to VP of engineering or lead architect and say, now, let's make a rule that starting Monday the 16th, everyone should have switched to a new version. Then it starts the whole bureaucratic process. But at some point, we are using a new version, everything is fine. So very simple situation. In case of monolith, you just use your IntelliJ IDEA, you use the refactor, all done. All the changes are done. What actually complicates this, for example, you can control the function and the code where it's being called from, because you have access to all the code repositories in your organization. But the problem is, how do you actually organize the repositories for the microservices? Is it like, if they lie down in separate repositories, then it will be quite problematic to find all the usage of the function and do the refactoring properly. Okay, you read about other aggregation, for example, you read about Spring, and then you adopt so-called monorepository approach. So now all your repositories are in one place. Then you turn on your IDE, and then you can go and make some tea, because it will take another 15 minutes to download all the dependency, because everyone changed their Gradle on a regular basis, and now your system needs to work properly, and you have to update all the code repositories, download all the artifacts, and probably the new M2 processors can solve it, but not perfectly. So that's another key. That's another key problem. How do we solve the repositories? How do we still make it efficient so engineers don't drink too much tea? Okay, where do we move next? Debugging. So we have, for example, QA team brings us the case.
Andrey, sorry, give me a minute. I have
Sure.
some kind of emergency. I will get back to you soon. Okay.
Of course. I hope that everything is fine.
Yeah, sorry for that. I'm back to you.
Right. So another very real situation from the production. So basically, customer support creates a ticket for the engineering team saying, hey guys, there is something wrong with this customer. Customer reported an issue. So in Monolith, you just go to the logs, you find the request ID, and then you can just go and collect all the logs from the system. How do you do it in microservices? Because now there is no, unless you pass it through all the system, the request ID, first it will be really hard to find all the traces. Then how do you connect it in one place? Because, for example, like in traditional Kibana environment, you will have to switch from one environment, do the search again and again and again and then again until you actually find what's going on. The same, so it complicates things for the engineering team on how to debug real life bug, and you have to solve it. You have to have proper monitoring system. Not going far from the monitoring system, performance.
Wait a second. Like not only monitoring, but actually tracing everything that is happening in a distributed system, right? Because it goes through different computation nodes, and you need to collect logs from all of them, aggregate them somehow, and filter by this request ID. So
exactly. Not going far from monitoring performance. Again, you have you go to the website, or for example, someone from marketing team goes to you and says, "Hey, this landing page loads slowly," and now you have to find which one microservice is actually slowing down the performance. And it's it actually reminds me of this popular type of games right now, the Among Us. You have to find the imposter, and all of them look similar in all these Kubernetes environments. Another, again, not going far from performance, the load balancing. The load balancing is supposed to be a very simple solution that works for decades at this point, but it was probably well solved for Nginx, for traditional API request. Going to the gRPC, for example, that we use in our environment. By default, gRPC doesn't support the load balancing properly, so you might have 10 different nodes, and 2 of them will actually do all the work. So you need to have the proper load balancing mechanism. You need to monitor it. We can solve it, but again, it takes time, it takes configuration, it takes knowledge to do it the right way. And I would say one of my favorite one is the deployment. When you deploy the monolith, obviously, you hit one button, and your production code is being updated, let's say, almost immediately, unless you use WebSphere. In any other cases, you wait until the deployment goes through all the nodes, update the code, and now you have your deployment. In case of microservices, sometimes you have to deploy services in the right sequence. Yeah. So it doesn't break anything on the production. What's funny here, if this situation is being combined with a sudden spike of the traffic and all your nodes being scaled up by your Kubernetes, then it creates an interesting problem. Which version will be scaled up? Yes, eventually all the stuff will be the same version, same last version, but for the short period of time, it might create an inconsistency in production. It might lead to production issues, and a question from the leadership team or from engineering managers: how do you solve this in the future? Because that has to be solved, especially if we are growing as a company, we have more and more traffic, because this problem will persist. This problem will continue to exist and bring more and more unsatisfied customers. I can keep going.
But I thought this problem was solved because correct me if I'm wrong, but nobody is rolling out features with the deployments. So they're rolling out new version of the code and then enable the features in feature flags or dynamic configs or whatever.
And this is right. So don't get me wrong. I would say majority of the microservice problems, especially for most of the companies of a certain size, is solved by this point. We have feature toggles, we have red and blue deployment, we have canary deployment, we have all these amazing technology algorithms and so on and so forth. But at some point, someone had to stop and think about it and find the right solution. So again, every case like this, unfortunately, can stop the adoption or can prevent company from doing something, I would say, business related, and shift the attention to technical details. It's not bad. It is reality, and this is reality where we live. I would say, if, for example, at our current volume, if we had the monolith, we will still have technical problems. It just will be a different type of problems. And don't get me wrong, I like solving the problems. It just takes time to find the proper solution. if that exists, because again, in many cases, you have to go through the Stack Overflow, you have to go through multiple forums. Right now, people can go through ChatGPT in order to find a solution. And you don't necessarily find the answer right away. So you have to iterate, you have to adapt, you have to learn. And in many cases, you learn by yourself. It's not like you can go somewhere, find the person right away, and this person will solve you. It will solve you all your problems from now on. So this is the state. It's not bad. It's not good. It is what it is. And I would say it is important to know all this stuff before you go all in and start designing your microservice architecture.
Yeah, thank you very much for that. So my question is, you mentioned several technical problems like deployments, monitoring, rolling out the same version, the interdependencies between services and so on. But the technical problems usually have some kind of a technical solution. However, what we don't observe in monolith, here, once we go into microservices, we have the distributed state and the problems of distributed systems, which are essentially very hard. So there are kind of technical solutions to them, but they're not giving you a lot of guarantees, right? So they're still empirical a little bit. So what to do with that? Are there any solutions or workarounds?
Distributed systems. In this case, I would say you have to go case by case, at least like from my experience. Whenever we have issues like that, then we gather around and think about, okay, this is the problem that we have. What could be the solution, and what is the trade-off here? Because there is always a trade-off. In some cases, the solution is just let's add another 10 servers and it will be fine. In some cases, we say, hey, the system will work perfectly for most of our users, but like there will be one user a day who will experience it, and we are okay just saying this user will either go to the customer support and they will solve the problem. So there is always a combination of who is paying the price. And you need to understand what you need to understand in this case, how big is the price for every solution that you found, and then you pick the what is the saying? You pick the smallest evil. So, and one thing that I would say, we actually discussing this yesterday, or in some cases that the solution is not technical. In some cases, solution is the overall company solution, like I mentioned, with customer support. We are fine if some customers will experience it, they'll contact customer support, or they might even leave the website, but that's the reality, and we are okay with that. So there is not even close to silver bullet, like silver framework or something like that. You just need to solve it by case. Don't rush it, and look at the problem from different angles.
Okay, so what I heard from you is that maybe you don't need this distributed consensus algorithm in your system, and maybe you just need some people in operations or support team that will handle like rare cases. Yep. So it's like kind of a problem that, of course, can be solved technically, but you would rather solve it at a business level than
I can give you an analogy. Sometimes people go crazy with automated testing, but in some cases you don't need to automate things. You can just use one person who do it manually. Quick example, for example, you want to test how your invoices look like when they're printed. So you can build a whole scanning robot that prints the invoice, scan it, then use some PDF algorithms to analyze it to print it properly. Or you can just have one person sitting close to this printer and like once in a while checking if the invoice is fine. So you don't need the whole technical solution here. You can just have one person in the right place.
Yeah, that's a great example. Thanks for that. Okay, going next. So basically, we covered the situation when we had a monolith and everything was fine except the scalability and the communication. Then we considered the picture where we have the microservices and everything is distributed, but it comes with its own set of challenges. But right now, does the industry search for some kind of a middle ground? Are there any solutions in the middle, like distributed monoliths, any kind of stuffs?
I think yes, because I can only speak based on the personal experience, but there's a thin line between what do we call microservice and what do we call a monolith, because at some point you might have so many functions inside one microservice that you can technically call it a monolith. So we have this like micro monolith architecture, and this is fine because there are a lot of constraints to which degree you can go crazy with microservice. And this constraint is very simple: how many people you have in your organization. Because again, you can put everything in every function in the lambda. You can build the whole infrastructure, but the question is who is supporting this, who is monitoring all this, and who is who hold the whole knowledge about all this stuff and how it actually works. So in some cases, you just don't scale your microservices, you don't split it, and you only do this when it's critical. So I would say this is the balance that we see, at least in our organization. Yes, we have some microservices that we would love potentially to split into some smaller entities, but they're fine right now. And we while they work, and this is one of the greatest rule I would say in IT in general, like if something works, don't touch it. So they work, we don't touch them, and we can focus on something else that is more critical at the moment. Yes, there is a big chance that at some point we'll have issue with the service. It might be not scalable because different parts of the service might have different demand from third-party consumers. But again, for a period of time, we can just add additional virtual service and that will be fine. So I would say this is a balance, and it's mostly dictated by the size of your team and how many engineers you can hire. In some cases, it's also dictated by the ambitions of the organization, because some people say, hey, we are 37 Signals is actually a great example here. They say, we are not some crazy founders who want to build the unicorn organization at any cost. Like, we don't want to raise crazy amount of money. We don't want to hire an incredible amount of engineers. So we actually let them go until 2 years later, like my organization do right now, unfortunately. So they scale very accurately. They don't go crazy with all the microservices. They actually moved away from the cloud to their own servers, and it works for them. So again, like many other examples that we talked today, it's not just the technical thing to keep in mind, it's the real life constraints, it's the business constraints that you need to keep in open, to which you have to keep your mind open when you are working on the big architecture things.
Okay, nice. Khan Academy just completed their journey of refactoring their Python 2 monoliths into a set of Go microservices, and they rewritten 1 million lines of code into those microservices, changing the language on the way. So that was crazy. We will discuss it later in my architecture newsletter, so I'll include a link to that. My question right now is how was it for you for the Scentbird? Like, have you had the microservices right from the get-go, or you transitioned to it? Did you have any kind of such migrations?
Yeah, that's a very good answer. The short answer is yes. We actually had multiple migrations because we didn't start with microservices. So the original Scentbird was actually the PHP template that was, and the CI/CD was just the FileZilla that I used to upload the code to the server. But that was like MVP version of the service. The first working system was actually a monolith written in Groovy using Rails. So that was from 2013 till 2015. Then at some point, we split one big monolith into two systems: the website and the website and the admin part, because and that's actually a good example of two systems with completely different demand from customers. Because in one case you have a lot of customers going to a website and buying it. In other system, you have two customer support agents working with the whole system. Obviously, they create a very different workload. And then over time, we started to introduce services based on the business need. For example, integration with the payment provider. It requires a different. It had different non-functional requirements. It had different flows, so it was put in the different system. Then we had microservices that was all about different jobs, not like similar to cron jobs, and so on and so forth. So every time when we saw that there is a big part of the system that now is becoming more and more important, and we have to treat it separately, then we were introducing a different service. I wouldn't say that they were microservices because in some cases they were still working the same database, they were using the same shared instances of infrastructure, but at least there were some service that were on the path to become a microservice. Then I would say it was 2018, I believe, 2017, 2018, when we decided we have to abandon Groovy, we have to abandon Grails, because unfortunately we don't see a lot of development in Grails as a framework. Most of the team members left and went to different organizations. And actually, one of the team members, Graham, he created a beautiful framework called Micronaut, to which we actually migrate right now. So before the Micronaut and after the Grails, we had Java and Spring. So we had to migrate our entire system to Spring and to Java. We're actually just finishing it. We still have one service that works, and for now we don't have plans to migrate it immediately. At some point in the next year, we'll do it. So yes, migrating from Grails to Java, in some cases, it's very simple. You almost change the extension of the file and you done the migration. Obviously, that's mostly a joke, but it was not that dramatic as moving away from Python to Go. The reason for that, these were still same engineers. These were still same JVM, same libraries, most of the same frameworks, and so on and so forth. So in our case, the migration was done pretty simple. So we never had this big changes that were very extreme. It always, I would say, was an evolution, and one thing slowly became something else without stress, without big change. I would say there were a couple of stressful things, like moving from several repositories into one mono repository. That was a big change that we had to do at some point, and that was a certain moment when we stopped working on the features, moved everything in one place, and it was working fine. But in other cases, it was always done on background with it didn't take 100% of our time. Yes, obviously it took longer because of that, but it was, from my perspective, it was a balance between working on the business features and working on the important technical things.
How did you do this migration? So at what level you were extracting a microservice? So was it a single feature, or I don't know, a single business flow, or a single function? How it went?
I don't have a not the right answer. I don't have a clear algorithm on how to, at which point to start to separate, at which point you have to separate a microservice from your big monolith. I would say in many cases, it's the gut feeling. In some cases, it's like when you hear too many WTF per minute from your engineers, then you actually start listening closer to them, and then you add the migration task into the roadmap. I would say in many cases when we see that when we work on business features, it actually takes more time on refactoring, or more time on solving not business related things. it's like more than 50% of the working on features, then you realize that you need something to do about it in order to bring back the engineering effectiveness. So then you decide, okay, guys, like we are doing too many changes around how do we work with product. There are a lot of consumers. We create inconsistency in data because here's monolith. It's just inconvenient. People complain about it. Let's move it to microservice. Let's agree how to use this, how to design it. Do we move it to separate database or not? And then let's start the work. And then we first do the technical part, then we do the estimation, and then we actually talk to our product managers and decide like, when we are going to do this and what will be the big roadmap project that will actually what would be the right word here, that will actually inject this technical change in it, because like we don't usually do technical changes by themselves, because okay, here's the big business project, then big technical project, then big business project. We usually make these technical changes a part of the big business project to as a reason to explain, hey, why do we need to do this? For example, we want to migrate to, I don't know, to third-party product information management system. So we have to move the product part on our side to different microservice. So the integration will be done in one place instead of having it in 10 different places. And then we start working on the microservice. So that's the more or less approach that we have inside. Yes, it's not perfect, but it works for us.
So basically, you're going with a practical approach. If something starts bothering you, you consider like moving it to a separate part. And okay, nice. Yeah, let's move on. So you said you used Groovy and Grails and then transitioned to Java, and you're using Macronaut framework for that. Any plans on switching to Kotlin?
No, thank you.
Okay.
Yes, let me explain. So right now, actually, most of the system is on Spring. We are slowly moving to Micronaut. There are a lot of things that need to happen first. For example, speaking of migrations, we are finishing our migration from Hibernate to Juke. And like we have certain reasons to do that. It comes from different team members. So why do it? So before we actually migrate to Micronaut, a lot of frameworks have to be sunsetted, like Hibernate is one of them. So Micronaut will be the next one. Why not Kotlin? I would say whenever there is a decision about the technology that should be used widespread in the organization, you think about many important aspects of using this technology. First, how fast team can learn it, and not learn just to write a hello world projects, but actually support it properly in production. So I would say this is one of the biggest questions that needs to be solved before switching from Python to Go, as Khan Academy did. Another thing is, what is the adoption of this technology and how easy it will be find in answer if something goes wrong. And I would say for me, Spring Boot is the most widespread technology in Java world. Yes, Micronaut is still pretty new. That's why we're not migrating everything to it. We are first testing it on smaller project, on smaller services to see how it works, how does it perform, what kind of issues we see there. But going to Kotlin will require completely change the coding paradigm. And a lot of people who use Java might not find it attractive, and they will say, hey, like this organization moved to Kotlin. Now I will quit and find another place to work. And that leads us to another thing to keep in mind is how easy to find a proper programmer, proper developer who can do it effectively and at which cost. Because why not to switch to Rust? We will have an extreme performance. It will work smoothly, but it's really, really hard to find a really good Rust engineer, and not everyone is doing. I would say at some point, people were obsessed with functional development, and we saw a lot of various languages, and a lot of companies wanted to adopt it. I saw multiple web frameworks created with functional languages, but the adoption didn't happen because it was really hard. It was, in most of the cases, it was just a fun thing to do. Yes, in some cases, there were proper use cases, proper scenarios where to use these languages, since I saw successful project even in some enterprises, in some banks. But for majority of people, it was no go. Same with us. Like for us, we rely on Java. Yes, like as a startup, like we are not using Python, we are not using Go, we are not using Groovy. We rely on something that works on 3 billion machines, and it works for us. We know how to scale it, we know how to support it, we know how to monitor it. So we rely on something that works on a very and have a very good and has a very good toolbox around it.
Okay, thank you for this explanation. Okay, so we have only quarter of the time. Let's move on to the next question. So, where do you think this whole notion of microservices go? Do we really go to this lambda approach when everything is a function, we just throw it in the cloud and forget about the runtime completely, or we're going back to the monolith, or we're searching for some kind of a middle ground? So where do the industry go?
I actually don't know, because obviously things like that change the industry landscape. In many cases, they just happen. So like you wake up, you read about this new concept, and then you start adopting like crazy, and it works. So I would say there are two things that might completely change the way how we create our software. First of this one is no code, low code tools. Like for a long period of time, I was personally against them. I was seeing them just a very simple tool to solve very simple problems. Right now, I use them in some cases, and I don't have to worry about infrastructure. I don't have to worry about monitoring. If I don't like something, I just pick up the phone and call the customer support, and that works for me. So I would say in many cases, there will be no need to build something yourself. You'll just find a proper low-code tool. Some of them are very interesting. They actually generate the code, and you can deploy it in your server if you want. And in these cases, there is funny enough, in this case, there is no legacy, no technical debt, because every time they just regenerate the code with all new frameworks, new versions of libraries, and you have a fresh code. So that's something to keep in mind. Another thing that might change the way how we build software and how do we approach it is the AI. Because again, in many cases, we will just use it as a tool that is running somewhere. Yes, on the backend, obviously, it is still it's still some servers, it's still some jar file or whatever. It's still running somewhere, but you outsource it and you make it someone else's problem. So I'd say these two things that we need to keep in mind when we build our software. Yes, inside it will be still a balance between monolith and microservices. I just want people to be less extreme about it, like think wisely about what to use. In many cases, it will be dictated by the not by big corporations, but by the market, like which engineers you can hire and where. I would say in the distributed work environment, microservices make more sense because it's easier for you to have it closer to your home, because like you can just run one simple server on your machine and everything else will be delivered through the network. So I would say microservices will continue to dominate until like one day we will end up in like quantum environment and it will completely change the way how we do the programming. So until that happens, it will be still same old balance between two things with addition of AI and low code. And this is how I envision we would move our technology stack for the next couple of years.
Okay, thanks for the forecast. It's really nice. And yeah, we can see something bright in the future, at least with AI tooling helping us, going through the boilerplate. Okay, and I think the last one for today is like we're talking a lot of about the microservices, but we still don't know how to pick up the proper size for a microservice. Like what techniques could help us? Are there any heuristics that could, guide us to the proper amount, and how to identify this border that like, hey, we're splitting it up?
Mhm. I would use another analogy here. How do you pick up weights when you go to the gym? Obviously, you don't start with the heaviest thing in the whole gym. You start with something that you can handle. The same should be, in my perspective, the same should be done with your microservices. Start with something that you can handle with your current team. Don't start crazy. Don't go extremely, because otherwise you will hurt yourself. And over time, yes, if you see that you can do more, do more. If at some point realize now microservices do more damage to you than benefit, just stop there, and you're in a good position. Again, there is no this is the maximum heuristic that I can give you. Like there is no line per code per microservice number. There is no proper jar size formula or anything like that. It's just the common sense of your team. The trick here, how to achieve it, you need to have a good engineering team. So let's say focus on that first, focus on hiring people who know about architecture, who think about trade-offs, who read a lot of real-life examples, who talk to other organizations, who learn how people solve problems. If you do that, then you will have the proper balance in your system. If you have, only junior engineers who read about lambda functions, then you end up with a lot of spaghetti in your AWS and the big AWS build. So start with the engineering team, build engineering team, your engineering team will do the rest.
Yeah, and pay attention to the members of the team that they hit the gym once in a while, right?
Exactly. And read Vladimir's Ivanov book about the architecture.
Yeah, thank you very much. The last one, because we have still some minutes for that. So you said that you need a good engineering team, right? But the number of microservices are obviously more than one. So how many microservices can one, let's say, average size team of 5 engineers, let's say, can handle? And where it's too much, how to pick up this cognitive load?
Depends on the complexity of the service. For example, if you're talking about the payment service, I would say one team per service, because you have to worry about so many things at once. You have to worry about the performance. You have to worry about the data consistency. You have to worry about the security. You have to worry about compliance, and so on and so forth. So in this case, one team will handle one service. If let's say, if the team is doing ETL processes, so in this case, one team can handle many things, because technically you set it up and it just continuously load data from one system and put it to another. That's it. So let's say the complexity and the complexity of the domain, complexity of the business logic, and the amount of non-functional requirements define how many services your team can handle. Because the more they grow, the more team has to monitor different aspects of the code, because we believe in DevOps environment. The team has to understand what's going on with their service in production, the less services they can handle. So fine enough, you go through some kind of curve here. You start with monolith. Then at some point you start creating new microservices. Team can handle team start by working on multiple services in the beginning. Then over time, the complexity of the services go up. You hit your ceiling in terms of how many engineers you have. So then you reach certain balance in terms of domain knowledge that team has in their heads, number of services they handle, and the complexity of the domain. Like this balance exists for a certain amount of time, then your business again starts to grow, launches new verticals, and then it goes through another cycle, and then it balances out again. Like a thermodynamic, what's the term here? Thermodynamic balance.
Okay. That's cool. I haven't thought about that, but yeah, sounds very reasonable. Okay, that's it for today. So I don't have any more questions. So I would just ask you what you would, wish to our viewers in their professional career and working with microservices in particular.
I would say think twice before you start working on certain project, not certain project, but certain solution for the problem you have, and think about the price that you pay when you pick one of the solutions. I would say in these cases, when people know the true price of every decision they make, they not only think twice, they think 4 times before actually executing certain thing. So think more, do less, and enjoy your work.
Cool. Thank you very much. Okay, it was a great pleasure to me having Andrey today with me. So again, Andrey Rebrov, co-founder and CTO of Scentbird, and loved guest. So thank you, my viewers, for attending this thing. So the recording will be publicly available in a couple of weeks. Until then, it will be private for Boosty followers and patrons. Thank you very much. See you next week. Bye-bye.